Good morning to honorable present here. Happy morning to all.
Good morning, sir.
Happy morning, sir.
Happy morning, sir.
Thank you. Thank
Happy
you.
morning, sir.
Thank you, ma'am. So, as a teachers, oh, definitely we have come across this question from the students, and so why I have to learn certain concepts. I just made this entire idea of delivering this session. I try to relevant with all the possible subjects, sciences and math. And students in at one stage, many of them are having this idea that why do you have to learn a plus b the whole square and to apply in my career or in vocation, or the electrons are liking behaving like a particle or as well as waves in a different experiment. That's a physics point of view. That's one of the toughest things that we learn. And I believe this radical abstraction in chemistry is a fundamental idea that one radical steals the other atom from the another molecule and it takes it. And homeostasis, I believe biology people can support this, might be a very abstract principle by keeping the internal conditions same, even though any external factors affecting it, most likely our body temperature. So these are the questions were really abstract. And when they're learning, they usually go with the idea that why I have to learn if I'm having a career in different path. How many of you experienced this? We can have small interaction on it. Have you all experienced this kind of question? I can see many of them are raising hands. Thank you. Thanks for your response. So, what was the response, your response to the students for these questions? What we can give generally when the students come with this question, how do we address this? Or any way you addressed it, you can proceed. Yes. Yes, sir. I think. Anyone possibly tell how did you address this?
Teachers, you can unmute and answer, or you can post your answers in the chat.
I can, yes. I think many of them having a certain level of the issue that the students coming up with this question, and we will be trying to give as much as convincing answer to them. And the problem with this answering is it lies in a very important factor that what is the outcome of their life when they learn this education. It's like I always tell my students when I'm starting the classes at June month or in the March month, we start for grade 12 and grade 11. We started. I always tell them that when you start working on the school or working at particular topic you are reading or you are learning a language, it won't happen in a immediate day or next day or a week after that or a month after that. You have to wait for some time to get a full result of it. Okay, so the entire the result of our process takes a longer time, then lower the interest we put into that particular process. So that's how the students are acting, and they are a bit doubtful about whether this process that they are going to give them a very big bounty in the end, or they will lose something or years. They feel like it is wasted or something like that. So in order to prevent that kind of a feeling, we have to convince them, keeping them spirit up in the starting itself. Say, for example, I will share my experience, how I addressed these questions. Say, when they apply a plus b the whole square formula, or it can be any other abstract topic they learn in the biology or in the chemistry and in the physics, we all learning around same kind of a subject, same kind of a topics all over the world. Everyone is learning the same level of concepts in the grade from grade 1 to or till grade 12. After that, the graduation will vary based on their career path or what kind of the path they want to achieve, or their preference, their interest. All those things influence their graduate level topics that they are choosing. So in the school level, everyone is actually making them learning with the same idea, same concepts. The reason is, say for example, yeah, the students pursuing career in medical, they definitely don't need a plus b the whole square directly applying to their life. But the problem is when they are encountering any difficult situations in their career, or they want to do certain calculations, they wanted to assess certain data that they provided to you, provide to them, or they work on situations where the social interactions and the economical some certain benefits, all kinds of a factor requires certain skill. That's a critical thinking skills. So a plus b the whole square equals a square plus b square equal to ab. This is not related to their career path, but it is related to their critical thinking. So electrons are behaving like a particle as well as a waves in a different experiment. That seems like a very abstract to whoever doesn't have a career in this physics part. Even we also find it very strange here in this part, in this context. But still, when we are trying to understand that concept, why it is behaving like it, we really go into our critical thinking part, and we are enhancing our critical thinking part. So if they want to become a chartered accountant, whether they don't have to study physics, no, they should need. So one of my physics professor quoted, even though you can be any accountant or any part, if you are a physicist, you will be doing in a different way. You are doing in effective way or efficient way that whatever task that you are assigned with. This is what the real idea. This is how I convince my student that you don't have to use it, that part really directly into your life, but the knowledge that is gained, or the thinking loop, electrical loop that is created in their brain, that actually that will be used effectively in their future careers. So that's the starting point I would like to start with. And I'm going with the idea that the transfer of learning is the major part that haven't addressed um, in a many of the aspects. Say for example, there was a statistics taken in the US that the trainings for the professionals, students, and in the schools they provide, there are a lot many trainings are going on, but the effectiveness of the training is achieved only when this transfer happens. They apply certain thing in their life, in their particular context, then bringing them to the another level and connecting with the um, next part of their future learning, or anything that they are currently learning with it. That's a major issue. So that's how I start my presentation, that is transfer of learning. So let's go with transfer of learning is very much important in the curriculum framework and the implementation of a curriculum. So most of the boards that are agreeing that the curriculum is not about including more and more topics. That means for a grade 12 or a grade 11 students, you cannot include more topics than that is determined, because the reason is they are grasping power and including a lot of information, actually making them cognitively loaded, so that they might skip few things that might be important, that will not be having that crucial role in their learning. It is about planning whatever the topic that is perfectly given or perfectly decided to the students. So a progression of transferable knowledge and the skills through those topics, even though it's a limited, but we have to give that entire transfer to one level of thinking to the other level of thinking. So transferable learning is a core purpose, is curriculum core purpose in the curriculum planning is once they learn certain idea, how long they are keeping it in them, applying into that their future learning. So how long they can utilize that learning into other part and they can implement it and execute it in any other future learning. Then how it is converted into a success, because there is a one complicated way that how do we analyze this kind of a transfer actually occurs. That is, we have only one tool finally all of a sudden in the school level, that is the units and the grades or the career that they decided. So how much they are completing, what is the grade they are getting, and what kind of a careers they are choosing, whether they are successful or not. Only based on this, we are analyzing. But there is a small factor we have to accept that there is no 100% a foolproof method that decides whether the students learned it completely or not. If a student scored higher grades in their career, in their school part, whether they learned it or they are able to transfer this learning, it's a bit doubtful. The reason is we don't have any amount of that proportional amount of evidences in all the statistics they have done in learning and the psychology of learning. All those things, we don't have enough evidence to support that. And also we don't have enough evidence that the transfer happened perfectly in the past with a certain curriculum or certain boards. So we why the reason of this topic is we have to promote this transfer of learning among the students so that they are well aware of what they are learning, what the skill they are learning, how they trained for that, then how can they apply it to the future topics or in the future parts of the life, then they can apply. So the without the transfer, your curriculum is simply a very small portion. Students will be remembering it for a short time. Then after that, it will be just put it into their subconscious level. They will never refer it. Finally, it will be disappeared from their mind. So we refer that as a short-lived concepts in their brain. So let's do the understanding of transfer of learning. Say for example, when we say lightning is a very bigger scary phenomena for everyone. It was a very huge thing that's happened. That kind of idea is in our everyone's mind. But lightning is one or the other way. It's a very simple mechanism, but it is a very bigger electrical spark. You might have noticed when you switch on and switch off the switches in your home, then in the backside of the switches, you can see a little flash. That's the electrical spark, which is exactly similar as the lightning. But we would have some kind of an idea that, okay, lightning is completely different phenomena, but the spark is completely different, smaller one, it is not of it. So this is when they understand the lightning and the spark that we are getting back behind the switch, they are similar, then there is a transfer of learning. That means they know that they are having a backing up theory that both are evolved from a same idea. Okay. Then another example is rusting. I think chemistry people can support me. Rusting is called a slow combustion reaction. Is it right? It's an exothermic reaction. It is very similar to the combustion engine. That means the ICE engine that we are using in our car, motorcycles, and all the vehicles that they use diesel and petrol, especially the fossil fuels. So combustion happens in the your motorcycle's engine or car's engine there, but we that was happening in a very fast. We are getting a heat. Okay, there is something going on in the engine. We will get amazed with it. But the rusting is also a very similar process. It is also exothermic. Still, it's very similar. But the connection between these two reactions, that's called the transfer of learning. We understand that both are having exothermic. They release heat, the engine get heated up, we are moving with it. So this is what we call it as a transfer of learning from one part of a thinking to another part. And say for example, we use explosives to move ourselves. If I say this statement in front of the students, they will get amazed with it. But it's a very simple idea that every day they are doing, coming to the school and going to home. That is simple controlled explosion of a gasoline is the one providing that mechanical energy to move vehicles. That means the movement requires energy that comes from the petrol. That's explosion. Literally, petrol or gasoline that we are having, the diesels, they are actually explosions. So from those explosion, the starting point of this engine is basically explosion. They initially went to the explosion, then they found with this explosion we can extract energy out of it and we can move. That's what they did in the previous centuries to develop this kind of mechanically advanced machines. So this is an example and better way to understand the transfer of learning, how it is happening. And this transfer of learning actually happens in current part based on what they have learned in the past, and with this both backup they can learn in the future. So whatever the topic they are going to encounter or a task they are encountering, they will be getting this idea. Again, the transfer of learning is fundamental to all, and it can be addressed in the lower level so that the students will have a stronger idea in thinking, perceiving, and processing informations, and all this kind of a works that will be made possible for them in their higher level. And in a very essence, if we want to talk about transfer, is basically a simplest idea as well as the backbone of the highest achievements. So it's providing simplest idea, then that will be formed into a very highest achievements in the real life. So what if we miss this transfer? Say we didn't provide the transfer, our student didn't learn this transfer. Say for example, the example I have provided, penguin is not seen as a bird. Everyone think that's kind of another type of animal. That's what the student's mind will think. Of course, we are familiar because we have around a few decades of schooling and another decade of for learning, and we encounter different examples. But as a grade 6 students or a grade 7 student, when we sit there, we just think about ourselves as their grade 6 students. These are pretty difficult for them. Say, for example, when we call a whale a fish, whale is not a fish. So the transfer of learning is not happening, then this would be the idea. Because sometimes it may not be very important as you think right now, but when it comes to certain decisions in a different scenario, this transfer does not occur. That will hinder all their future learning. And also we see bat as a bird. So they are animals, and we can say that the deer and the whale both are same. They are similar category, similar animal kingdom. They are there. So that's what they are saying. Nobody will notice that in the level that whale and deer are the same behavior. They are in the sea. They are living in the land. They are completely different. That's what the difference they see it in their lower level grades. So how do we implement it? I'm just giving a very lower example. Then I will give a grade 8 level example that how this transfer of learning can be included in our everyday teaching. So for a basic level, say in the starting, a child who is adding a certain numbers. Say for example, 3 plus 2 equal to 5 is an abstract part of the mathematics. But the same math can be included in this way based on this logic. I have a 3 apples, 2 apples, added, I'll get a 5. So this is what they call it as a transfer of learning in a very lower level. So your apples acting as a medium, you can put any kind of a countable chocolates or anything, you can put it there, and you add it with another group of chocolate, you will get this one. So we try to connect with the 3 numbers of certain objects, say apples here, to the number 3. That's an abstract form. Then 2 apples to the abstract form of 2. Only thing is we are doing the learning of information is 3 is equal to the 3 apples, 2 is equal to the 2 apples in the count. Finally, we will get a 5. So this transfer actually enhances in very lower level. Say when they are we are entering to the school level, this kind of a plan will actually works for them. So from abstract to their basic logical reasoning, or from logical reasoning examples to the abstract examples. Now, I'm going with the checkpoint physics. Those who are in Cambridge, you would know that. Others, the checkpoint level, we usually call it as a grade 8 level. So grade 8 level, this is one of the topic in physics we usually teach. When we take a metal, and metals are a good conductors of a heat, that's why we are using it for cooking and other purposes. When we heat it in the flame, the heat will be transferred very fast. So this is very abstract level. If I say this, a rod heated with the burner, heated in the burner, and the one side will get heated up after some time. For example, the hand which is holding at the end, you can see that there is a gradient here. The heat is in the pot here, and the end the heat is going to travel. So that is given by that red color gradient is there. It's actually a faster travel they can experience if they do it. It's a very simple. When we put a spatula in the wok when we are cooking, it's get heated up if we put it continuously. Similar phenomenon. But for them, this is a very abstract. When I say this experiment, so what I'm going to do with them, I'm going to modify this idea to do a certain experiment that is simply a transfer here. Say, for example, we take a candle or a burner, then we fix the metal with the different thermometers. The thermometers are actually located equal distance from each other, so that I can tell initially. That means when it is closer to the flame, the metal will get heated up very soon, faster, higher temperature. The thermometer will show higher temperature there. Then when I go little further towards the right hand side, the thermometer shows little lower. Then the third one would be very less. So again, it's another form of experiment, but still it has its own abstract idea that the temperature shows there is a line here that is decreasing when you go away from the source. After some time, the temperature will increase one by one. Say, for example, the first one reached the higher temperature, then after some time, the second one reached higher temperature, then third. So this actually shows the thermal energy conducted or thermal energy moved through the metal. Now, I will be asking them to design an experiment in a third one that I'm showing here. We have a metal rod and it is heated up in the one end. Then we attach, say for example, we attach with the help of a wax or something, so that we attach the pins at equal distances. So pin 1, 2, 3, 4, they are attached here. So you can easily predict this experiment. Say for example, from the candle, the thermal energy going to travel towards the left hand side. So as the thermal energy travels, the pins will be dropping one by one. So they can have a stop clock and they can work on it. They can measure the timing it takes. That actually makes them to think in a very clear way that how the thermal energy travels. It travels faster in certain material. They can even compare it with a different metal. That really enhances lots and lots of possible experiments just with this one abstract idea. This is what the transfer of learning is. Is it clear how have we made a change into the part and we worked on it? Is it clear
Yes,
so
sir.
far?
Yes, sir.
Yes, sir. It's
Thank you.
clear. It's clear.
Thank you, sir. Thank you so much. Thanks for your response. So this is one of the part we usually do in our checkpoint um, papers when we are fixing the papers or when we are doing the experiments, laboratory experiments, we work on it. So I welcome everyone to try this, but it definitely will take some time to work and prepare on it. So this idea of connecting the transfer, how the transfer happens from one abstract concept to other concepts, that actually leads to the higher achievement. That's what we have seen in the previous part. So I have lots and lots of examples to tell you this. There are some cross-disciplinary transfer occurred in previously. That's why we are enjoying it. These kind of a very sophisticated, highly technological instruments that they never would have imagined in their 1950s or 1900s. Say, for example, the invention of a lamp, I mean, electrical lamp. After Edison has discovered that, and many people have come across with this kind of a lamps, those bulbs, especially the filament bulb. There is a filament inside that which glows. That is the one is the backbone of production of this integrated chips. That means we usually have that very building block that is a diodes that actually builds up to transistors. Those transistors are there in the computer processors. Basically, if you want to tell the layman terms to explain to the students, we can say that the transistors, diodes, transistors, and the millions of transistors combined, you'll get a processor that we are currently looking at or using it in our laptop. But the starting point of diode actually comes from the light bulb. Simple filament light bulb, they worked on it. They able to control the current in the diode in one direction, not in the other direction. This is actually giving that breakthrough idea that there was an initial computer component called vacuum tubes. From that only, nowadays we are having very compact laptops and notebooks that we are having. But those times they were in the size of the room or something. So like that, there are many examples. I don't want to go through with everything, but still I want to highlight one fascinating thing. In astrophysics, astronomy and cosmology, where we study about the solar system as well as the stars, then other bodies in the space, say for example, we talk about the black holes, we talk about the gas clouds, we talk about nebula. All these objects are there in the sky. Um, there was a one invention, that is, they discovered that idea of hydrogen gases, usually not closer to the solar system, it's far away, so around 1 billion 2 billion light years you have to go. Those, after that, there is a gas clouds of a hydrogen. They usually emit a radio waves. Those radio waves will reach the earth and we analyze it. So that is highly remote phenomena. It's very core of their cosmology related thing and astrophysics related thing. But that phenomena, that means hydrogen atoms can respond to the radio waves and they can emit the radio waves. That's how we are having MRI scanner right. The person who involved in astrophysics finding this hydrogen atoms emit or absorb the radio waves, the same exact phenomena used in our tissues, because our tissues contains mostly a water. So hydrogen is present there throughout our body. So you can check our or we can diagnose our any kind of illness with this kind of MRI scanner. That was a very advanced tool. Then we know that our cameras containing CCD sensors, all our cameras, they are actually the developed because of the requirement in astronomy to take a photograph of very faint stars. Like that, the very example. And in the case of engineering, biology, we know that the natural structures and how it is optimized to work with the entire system. Say, for example, how our hands are working. We have certain number of joints, those joints facilitating to take any objects. Am I right? Our fingers, each and every joints are determined to do their work and not bending in other way. All these informations are considered to make a robotics or the aerodynamics objects or the ventilation kind. They usually call it as a biomimicry, where we design our mechanical systems or electrical systems, electronic systems with the help of the biology. Simply how we are making them to, even the transfer of learning is happening in the neural networks, how they learn this large language models here. So in AI, it's very much useful how the brain is learning, the same way they are making the AI to learn. So, how do we plan to execute our ideas here? For example, I want to do the transfer perfectly. What should I do? So, I have to find out identifying core ideas. So, whenever you teach certain topic, tell them what is the skill they are using here. Say, for example, when they plot the graph, they are deciding the scale, so they are able to scale it to any other situation. Say, for example, they are deciding scale for the graph. They are doing 1, 2, 3, 4, 5 or 10, 20, 30, 40, any scales they choose. That same kind of a scaling skill will actually make them to explain certain things in this way. Say, for example, the mass of the whale is equals to 50 elephants, so 10 elephants. Okay, so those kind of a scaling actually related to your graph based scaling here. So these are the very simplest examples. Whenever you come across the certain topics, just to put a tag, okay, this is a skill the question paper the teachers are expecting, the examiners expecting, you have to write this, you have to work on. That gives them very clear picture that okay, they will take the skill in their brain, and whenever you give the similar situations, even a slightly different also, they can definitely go with full confidence to apply those skills. Then designing varied learning experiences. We can use different simulations and experiments to stimulate the skill learning idea in their brain. We can simulate, we can create a lot of wires in their brain. That definitely help them to understand the other subjects also. Then explicit connections. So every chapter or in the introduction part, in the end of the chapter, I see in the Cambridge, the introduction part, they provide this idea. And in the CBS and other curriculum, in the end of the chapter, they'll give clear idea that why we are studying this chapter. They provide the information about the scientist who discovered and what is the contribution they provided, how it changed the life in the world. Everything will be provided. Usually, we don't emphasize it because of our time constraint, various other problems are there, but still they are actually enhancing the spirit of learning. So they will understand somehow, okay, this is how it can be achieved, or it can be used as a dinner table conversation that actually enhances with their appearance or their position in front of their friends or in the relatives. So this making explicit connection make them to put them in the very important part of the other's life, so that they will be feel valuable, they will be motivated towards learning again. Then encouraging the reflection once they are observe the skill and they learn the skill, ask them to reflect on it. How do they apply it? How do they work on it in their everyday life? Any minor thing they change in their life, still we can appreciate based on their reflection. So we are in the concluding part. Um, we think about highlighting principles, multiple contexts, and getting the abstracted content and put it into a very generalized way, and giving it to, I mean, scatter it to all the possible ways they can fix it. That gives the very important part here. So when we go with the teachers, what are the gains that we do? Say, for example, for 6 to 8, we are actually a bit struggling to take a question paper which actually tests the learner's ability completely. So when we map the skills, so you take only the skills, don't look at the chapter, don't look at the titles or anything. Just take the skills, try to relate it with the question. That definitely will give a lot of new ideas, and the questions that we can take, that is very similar to very creative question they make in the Cambridge. So the final part, I would like to give this my respect to this Robert Haskell. I actually refer this content. The transfer of learning requires a mindful abstraction and consciousness in application. This is a quote that he has mentioned. This was actually completely about transfer of learning in the how we do it in the cognitive way and a regular process, how we plan it. All these, the essential idea that I have taken from this book, you may, I mean, I welcome you to recognize this book, and it is available. Partial book is available in the Google books. You can read it freely, few chapters. They are really very helpful for us to plan things. That book name is Transfer of Learning, Cognition and Instruction by Robert D. Haskell. And I would like to thank Madan sir to provide this kind of learning. I mean, he gave the idea that this transfer actually very much helpful, and it's important to work with the teachers might need it, some of them. So thank you so much, sir. I think we can. I reached my time. It's 10:06. If you have any particular questions, we can discuss.
With the AI in picture, transfer of learning is so important nowadays. So it's not just anything, whatever we do, AI can able to do it.
Yes.
So if the students understand better on what is being taught, and if they could able to transfer their learning in another scenarios, other discipline and another environment, nothing like that. So thank you, Joe sir, for this awesome session.
Thank you so
So
much, sir.